And welcome to this next Unit 4.4 video on water pollution. In this video, we'll be having a think about measuring water pollution. Let's just remind ourselves about the big question. So one of those big questions that we're going to look at is to what extent solutions need to be found. And one of the best ways actually to deal with water pollution is to stop it from happening in the first place. So clearly you can see that if you're able to measure water pollution, it indicates where action needs to be taken, both preventative action and action to clear up the water. So there are a wide range of parameters that can be measured directly and indirectly to test the water quality of aquatic systems. Standard tests on rivers and drinking waters can be performed with portable equipment and chemical test kits. We'll probably be doing at least some of these during this course, during our lab work. There you could look at biological oxygen demand, chemical oxygen demand, turbidity, ammonia, dissolved oxygen. All those things can be measured, along with a range of other pollutants such as nitrates and ammonia. So when measuring these chemicals, we could be looking at things in two ways. First of all, we could just merely be looking for the presence of chemicals, which in any concentration would be deemed as toxic, or other chemicals that are less toxic, we will be looking for a specific concentration. Above that concentration, then they are considered to be toxic, and the water is said to be polluted. There is some complications here when you're thinking about this in an international way, because different countries have different environmental standards. Just to have a look at what some of those standards would be. So for dissolved oxygen, typically for a very, very healthy water quality, we'll be looking at 75% plus dissolved oxygen. 10 to 50%, it'll be considered as polluted. And less than 10% oxygen concentration will be associated with raw sewage. You can look at other things as well, such as phosphates. So for phosphates, we're looking at less than 5 milligrams per litre of water. So each one of those has each of those chemical pollutants has a different indicator. But as I said before, the complication arises when you're looking at things internationally, because there are different standards. So one of the big ones that we look at is biological oxygen demand. Biological oxygen demand does just that. It measures the amount of oxygen the organisms within that water sample would consume. And so the way that you do this is you carefully take a sample of water, you measure its oxygen levels, then you put it in a dark place. That's very important because you don't want photosynthesis to occur. So you put it in a dark place at 20 degrees centigrade and you leave it for 5 days. After those 5 days are up, you carefully measure the oxygen concentration, and the difference between the oxygen concentrations before and after, that would give you your biological oxygen demand. And we're going to undoubtedly have a look at that and do that in practical terms in the lab. So as you said, there are a wide range of things that can be measured directly and indirectly. So we're going to think about each of those in turn. So when we're looking at something directly, that's when we're actually measuring the chemical composition of the water. So they are direct measurements. Alternatively, we can look at indirect measurements, and that's principally where we record the species. So in contrast, indirect measurements record the species present. They don't actually measure the chemicals in the water. There we would be interested in, especially interested in indicator species, and we're going to look later on in a bit more detail what specific indicator species would be. We would also be interested in indicator species of both good water quality and bad water quality. In addition, we'll be looking at overall biological diversity. So just to review that, there are a wide range of parameters that can be measured, that are used to measure water quality, both directly and indirectly. This is, I think, really the case of the more data that you can have, the better. So it's not so good just to rely on one data set. It's good to have multiple data sets taken up multiple times and in multiple locations. I think I've got the order of my slides a little bit mixed up there. Sorry about that, guys. So yes, so when we're looking at biological oxygen demand, so there you can see that if the biological oxygen demand is milligrams per litre, if that demand is between 1 and 2, the water quality is considered very, very good. If it's 100 or above, it's considered very, very poor. So just to help you to understand why we look at biological oxygen demands and how that works, it's the amount of nutrients that are in the water. And what will happen is that those organisms in the water would consume those nutrients. And when they consume those nutrients, they will be consuming oxygen as well. The other thing that can happen here is if you have a very, very large amount of species, they could ultimately die, and when they die, they are going to rot down, and they're going to rot down in an anaerobic environment, which is never a good thing. Okay, so we'll be looking at a little bit more detail exactly what biological oxygen demand is and why are we interested in biological oxygen demand and how biological oxygen demand is an indicator of water quality. It's all about the nutrients that are available in the water. Okay guys, so I hope you found this video useful. Sorry I got the order of the slides a little bit mixed up there, but hopefully future videos will give you a bit more clarification.